Welcome to Sc130 Module 3. Now in this module we're going to build upon the work that we've done previously. Just to recap. First of all, the matter, in whatever phase, is made of particles. Now particles have various shapes and forms, but key to that is the atom and the atomic structure of a compound or molecule. Now we're going to look at that process of forming compounds. What is it that, as we said previously, that carbon bonds with oxygen naturally to form CO2? Why is salt NaCl? Why is it that? Why do they combine together? So we're going to look at this concept called valency. So let's go to the web page and have a look where we're heading. So it's in the chemistry section, and we're going to be going atoms, element, compounds, and periodicity. And that's something we can get our mind around today. So we'll scroll down and have a look, because we've had a look at some of this previously. We're going to start, probably the meat of what we're doing is the concept of valency and periodicity. So atoms, nucleus with electrons whizzing around. Well, the parts where atoms join together is in the electron shell. So it's all about balancing the orbits and the requirements of our table. Now looking at a periodic table, we have these are called the transition metals. They're a little bit different. So we're going to mainly be considering the concept that happens in the top part of the table here, and just sit and keep to the side for the moment this area here. So there's all our elements. This is going to be an interesting, a very important video, because what it does is map out, using Bohr's model of the atom, about how many electrons are in the outer shell. Now the outer shell is where the electron clouds meet together and bond. So what's happening in the outer shell is most critical importance to us. Going down the right hand side is we've taken the transition metals out there, that's the squiggle there, and we've had a look and we've mapped the outer shell here. For example, in the second layer, lithium has 1 electron in the outer shell, beryllium 2, boron 3, etc. Carbon's got 4, it's in the middle, and then there's 5, 6, 7, and 8. Now these ones are called the noble gases, and they are unreactive. They don't see it. That's why neon and nitrogen is not nitrogen. Neon gas is used because it doesn't react for things. Now that's what, in a sense, every atom wants to be. That is a completely balanced outer and full outer shell. So a key principle of how atoms combine together is they will combine to form a full outer shell where everything is balanced. I use this sort of metaphor. It's a bit like the washing machine or a dryer or something. It's in balance. If you take something out, it gets out of balance. It's no good. It is not stable. So energetically speaking, the optimum energetic and lowest energy is the most balanced state. So things want to have 8 in the outer shell. Helium's a little bit different. We'll talk about that another time. But essentially, it's called the octet rule. Octet meaning 8. So we want to establish atoms will react to form a low energy stable octet, 8 electrons in the outer shell. What does that mean? Well, the concept of what is in the outer shell is called the valency electrons. Now it's shown pretty well here. Now we're going to the second layer here, and we're looking at neon. And in the outer shell there's 2, 4, 6, 8. On the inner shell there's another 2. That's why its number is 10 altogether. But the one we're interested in is the outer shell, the valency. Notice here they have a full outer shell. The valency is 0. Now let's go back to where we said lithium has 1. Now underneath lithium is a full outer shell of 2. It might be balanced, and sodium, for example, has a 1 as well. So all of these have 1 in their outer shell, and therefore they behave chemically fairly similar. They have 2, etc. They have 3, and that has 7. So whatever vertical line or period, it's sometimes called, corresponds to the valency. So the essential periodicity go 1, 2, 3, 4, and again it goes 3, 2, 1, and 0. Now we'll talk about why it goes backwards, and the middle point being carbon. So valency is to understand that the periodic table is organizing those periods for a particular reason, because that actually communicates something in terms of their chemical properties. This one here, a chemical formula, will understand the nomenclature. This one here really is a very good video that unpacks and shows you, for example, why things bond together. And we'll talk later about common ions. Back to the heart of the matter is here. For example, salt is Na bonding with one chlorine atom. Now, Na has how many in the outer shell? 1. Chlorine has 7. So what does chlorine need to get to be an octet? It has 7. It needs 1. So sodium will bond with chlorine, combining together to form a ring of 8 around sodium. So what sodium has done is given up its electron, and chlorine has taken its electron. Chlorine's happy. It now looks like argon because it's got 8. Sodium's lost 1. You think, is that good or bad? Well, if it's lost 1, have a look down here. It's lost that outer one. But underneath that, there are 8. In other words, chlorine looks like the 10 neon. So it's now stable. And chlorine looks like argon. It's now stable. So those two things come together and creates a chemical bond, and therefore the formula is NaCl, Na1, Cl1. Now, you would say, so what's the valency then? So if sodium lost a negative charge electron, then what's its overall charge? Well, it's +1, so its valency is +1. Chlorine gained an electron, it gained a negative, its valency is -1. Now, +1 and -1 equal 0. So, in a sense, we can look at the periods and say, well, how will atoms behave? They'll behave and react together to form compounds where the overall valency is equal to 0. So that's a key point about how chemicals combine together. Let's pick something else that we know perhaps. What about, H2O? Those 2 hydrogens will bond with 1 oxygen. Well, let's go back to our valency. Oxygen, where is it? There it is. It has 6. It needs 2 to be 8. It needs 2 negative electrons, so its valency is -2. What's hydrogen? Well, it's got 1. Therefore, if 1 hydrogen gave it to oxygen, it would have 7. But if another hydrogen bonded with oxygen, 2, you'd end up with 2. Oxygen would now have 2 extra electrons, being 8. Hydrogen would have lost its unbalanced 1, and each in 2 cases. So 2 hydrogens will bond with 1 oxygen to go H2O. Let's add up the valencies. That's 2 hydrogen, that's +2 overall, and then oxygen is -2. Well, that equals 0. That works. There's no compound that, if you have magnesium chloride, for example, how does it differ to sodium chloride? Well, magnesium's got 2 in its outer shell. It's got 2 electrons to give away. It's got a valency of +2. And chlorine, again, needs 1. Well, if I've got 2 to give away, well, magnesium bonds with 1 chlorine, gives 1 away, and another chlorine gives a 1 away. We end up having 2 chlorine atoms that look like argon, and the magnesium's got rid of its 2, and it now looks like neon. So let's look at so the formula is MgCl2. Look at the valency now. That's +2. Chlorine is -1. Well, 2 lots of -1 is -2. +2 up valency, add them together, you have it to be 0. Can you see that you can use the periods, and that would apply to everyone under here? Now, one of the more interesting one is when you get towards the middle. Now, carbon and silicon and so on, it has options. It's got 4. It needs to be 8. It can either gain 4 or lose its 4. Well, it does both, depending what it's reacting with. So carbon, for example, reacting with oxygen, the formula answer is CO2. Well, oxygen needs 2 each, and carbon's got 4 to give away. So 1 carbon will react with one oxygen, give 2 away, another oxygen to give 2 away, so CO2. That works fine. That's great. It's CO2. What about when it bonds with hydrogen? In the same way, it will actually take from hydrogen. So instead of giving it away as it did with oxygen, it will actually take from hydrogen. So hydrogen's got 1 to give, and it needs 4. So 4 hydrogen atoms will bond with a carbon atom and go CH4, which is methane gas. So carbon can either give it away or take, depending what it is. But at the end of the day, it becomes balanced, and we can still use the same rules of valencies to answer those questions. One of the reasons that we have an organic, they call, universe is the fact that it's carbon-based, is that carbon has the ability to do both of those things. So the whole is a very strong bonding atom, and very prevalent in God's creation. So to finalize then, what we will do is, when we look at those things here, is we'll read all those things and work out what are the chemical formulas that then we can use when knowing chemical reactions. A little bit of it answering to that. Well, some atoms or clusters of atoms are not singular. They form ions. For example, we call them polyatomic. So some things like the hydroxide ion, you may have heard of something like sodium hydroxide. Well, OH has a valency in a sense. It forms an ion of -1. So it behaves that way. So if it was sodium hydroxide, sodium, recall, is +1. Hydroxide is -1. We want it to equal 0. So it's NaOH. Would be, for example, how we would use those. So we can use the ions in the same way, the ionic plus and minus, in the same way we can use valency. So that's the overall picture. So what we're going to do in your worksheets and things today is practice those skills. So start with the periodic table, look at those videos, go to the end of the homework and revision, do those exercises, and be really competent about what would a formula be. If you're not sure, drop us an email and see if we can point you in the right direction though. So yes, this is a really critical lecture. Hope you enjoy it. Hope you got your mind sharp on this one.